Welcome to episode 8 of Let's Talk About Electric Vehicles. My name is Teresa, I'm an economist, and I answer questions about the electrification of the transport system every week in an informative manner from an unbiased scientific perspective. I usually refer to results from academic research. Last week, I started a 3-part series about supercapacitors. We have learned about what a supercapacitor is and what makes it different to a battery or to a conventional capacitor. And we also talked about how it has shaped the energy sector since its first launch in the 70s. In this episode, we will continue by looking at other sectors where the supercapacitors are already commonly used. Just a little disclaimer. Today is full of genius technology inventions. I'm so excited about sharing with you what I found out about how the supercapacitor, for example, improved the industrial sector. So finally, in the third part, which will be published next week, we will solely focus on the automotive industry. And without further ado, let's talk about supercapacitors. Supercaps have already been commonly used for industrial machines such as forklifts, shovel trucks, harbor cranes, and so on and so on. Basically, any machine that needs very quick and powerful energy in irregular frequencies could benefit from a supercap. The recently imposed CO2 regulations and the increasing concerns about danger and health related to the indoor use of fossil fuels even enforced the implementation of supercapacitors over the last years. Forklifts are typically the sector where new technologies have the best chance for launching, since the production volume is much larger than of, for example, heavier machines. However, you find supercapacitors also in heavier machines, where they are usually installed in combination with diesel motors. So they help out in moments of high power requirements. There's typically 2 motors in these heavy machines, one internal combustion motor, like the diesel motor, and the electric motor, and they are working together. Supercaps are typically not the only energy storage for this electric motor, but they're usually combined with a battery or with a fuel cell energy storage system. And now listen carefully, because this is what I found so fascinating and simply ingenious about supercapacitors in the industrial sector, because they not only assist in moments of high power demand, but they make it possible to recover the energy from braking and drop maneuvers. And thanks to all of these features of a supercap, for example, the forklift by the company Komatsu saves 20% of diesel fuel and reduces the CO2 emissions by 35%. Komatsu, this is a Japanese company, and the forklift was launched in 2007. An interesting fact. Interesting fact. Depending on the electrolyte material, a supercapacitor can have different characteristics. In particular, we distinguish between organic, aqueous, and room temperature ionic liquids. Using organic electrolytes brings high conductivity, more stability, and higher power, but it comes with safety concerns as organic liquids are inflammable and toxic. Then on the other hand, the aqueous electrolytes, they are much safer, but their stability is limited, unfortunately, to a maximum voltage. And then to the third type, the room temperature ionic liquids, they are safe, they are stable and powerful, but they are also the most expensive ones. The company Komatsu that I've mentioned before is also the company that launched the very first hybrid excavator on the market. The diesel engine of this excavator is still the primary energy source, but the upper part, this turnable upper structure of this excavator, is powered by an electric motor. And here the supercap enabled electricity savings of 25% and fuel savings of 41%. And similarly to excavators, There's also earth-moving machines and crushers that already benefit from Supercap, as the Supercap can smooth these high-power peaks. For example, in 2012, a caterpillar with a hybrid hydraulic shovel was introduced to the market and recovers energy from the cabin swing deceleration and from the boom down movements, and then it resupplies this energy that it has recovered when required for high power peaks. And here the reports a fuel savings of 25%. An interesting fact. Another interesting fact: the temperature range in which supercapacitors can operate is much larger than for batteries. There's still a capacity loss of 0.5% per degree Celsius, hence a temperature variation of 80 degrees leads to an 8% decrease in capacity. But supercapacitors are functional for temperatures down to minus 60 degrees, depending on the specific type. For comparison, a lithium-ion battery cannot really perform below 0 degrees, and the lead-acid battery is limited to minus 20 degrees. Even the weakest types of supercapacitors have a wider temperature range than batteries. Not only the industrial sector, but even in consumer electronics, the supercapacitor is already in action. This market is a bit more challenging for manufacturers since it involves very tight time frames for the design development, and it makes the manufacturing very time sensitive and very costly. But nevertheless, there are some applications where the supercapacitor already comes in quite handy, for example, to secure the writing speed of memory backup, or for emergency power to protect hardware in case the primary energy source fails, or, for example, for smartphone flashlights. Then there's one more industry that I would like to mention today where supercapacitors can play a very important role, which is aerospace. Okay, this is it. This is all I have to say for now. You have to wait for the third part for more information, especially about the automotive sector. To sum up what we have learned in this episode, supercapacitors are installed in forklifts and other heavier machines in combination with diesel motors. So they achieve savings in diesel fuel, and they also achieve savings in CO2 emissions. But even in consumer electronics, the supercapacitor comes in quite handy, as it assists, for example, the flashlight in smartphones, or it also guarantees the writing speed of cache memory backup. So I don't know about you, but I can't wait for next week, where we will finally solely focus on the transportation and the automotive sector. I really hope that you've enjoyed this episode. Please feel free to reach out to me for remarks or further questions. I learned so much from you guys. I wish you a wonderful remainder of the day, and let's talk about electric vehicles, or actually, let's talk about supercapacitors next week. Bye!